Okay, so we're going to also deduct half of, or less rather, we're going to less a half of the column, because it's half of the column that is entering into the 6 meter. So we're going to less it to get the actual length of the beam. We're lessing this part here, lessing this part here to get, and this is half of the column, and the column is 254 from our drawing before. This is 254 by 254. So dividing that by 2, we're going to have 127 mm. So converting it to meter, that will be 0.127 meter. Then we would deduct everything to get a final length of the beam. So, all right, for the allowance for fittings, we're starting with the top angle. So from our drawing, the top angle for universal beam 305 by 165. Top angle is 76 by 76, 14 mm thick, 2 kg per meter. Okay, so let's describe that. 76 by 76 mm, 2 kg per meter. For lengths that are not up to 500 mm in measurement for steel work inclusive, we don't include it when we are booking. So for this case now, for a top angle plate, the side that we are giving is this L-shaped side. That's from here to here 75 by 75, 76 by 76 rather. However, there's still going to be a length it cuts across. So what we do now to get that particular length, that's why it's measured in linear meter, is to take the width of the side is attached to. So in this case now it's attached to, since it's been 305, this is attached to this beam here. So it means the length from here to here, that's what we're going to take. So what's the length from here to here? We simply use the length that is on the beam, which is 165. So therefore top angle cleat to be 165. So that approximately 0.17. Since it's 7 in number, but it's going to be on both sides, so you can do by 2 by 7. So let's do by 2 by 7. So by the time you multiply that, you have this as your answer. Okay, so we'll do the same thing for bottom angle cleats. All right, so for its dimension, it's 102 by 152 mm, which is 11 mm thick. Okay, 2 kg per meter. Yeah, the dimension of the bottom angle cleat is different from that of the top. So the bottom carries most of the load, so that's why it has a bigger, wider area. Okay, so it's going to be the same length, going to cut across the same length because it's attached to the beam as well. Okay, so 7 times 2 is 14. That's why I'm using 14 here. So either ways it works fine as long as you get the answer and you understand what you're doing, right? Okay, having done this, the next thing we're going to be considering is for beam 254 by 102. So it's basically almost the same thing. So I'll be quite fast because we've treated most of it. So from our plan, it's our beam 254. So 1, 2, 3, 4, 5, 6, 7. There are 7 in numbers. And if I were to look at the arrangement of the columns side by side, so this one is similar to this, and this, while this one is similar to this one. So we have 5 of the same configuration and 2 of similar configuration. Okay, so this is going to be half of the column, and the column is 254. Yeah, so 254. Then you have 127 on this side, 127 on this side, add it together, then you less it by the length. So from this point to this point here is 4 meter. So you're going to be subtracting 254 from 4 meter, or 0.254 from um, 4 meters to get the actual length of the beam that's going to span it from here to here. So let's guide right onto it. So it's going to be 4 meter. Now let's, and this for the A, which is the one that has both sides of the beam attached to the column that's facing side by side. Both sides are same. Um, okay, so the time we less this, we have 3.746. Okay, so this is half column. I multiply it by 2, which is 2 by 127 for clarity. Okay, so the B, the second beam, which is this set of beam, one is facing having like an I shape, and the other is like a H shape. So for 2 of them now, that's what we'll be considering. So that's we're going to be lessing half of the column, but we're not going to be doing it in 2 places, because in this one now we have just the web, the thickness of the web here to deal with. So our thickness from where we started earlier is to get at 6 mm. So we'll deduct, or we'll less 6 mm as well. Yes, so we'll have this as our answer. So now for us to book, we have 3.75 by 3.87. So 3.75 is 5 in number, and y 3.87 is 2 in numbers. So by the time you multiply that, you have 18.75 here, you have 7.74, you have 20, then you add them together, you have 26.49. Take down our description. For the top angle clips, it's similar to what we did before. So we have its length as 76 by 76 by 11 mm. That's the thickness. So its weight is 2 kg per meter. We add our coding. So now, what do we see in our drawing? So in our drawing for beam 254 by 102, 76 by 76 as a top angle by 11. written here. So how wide, or how long rather, will this 76 by 76 be on this beam? So it's taking the width of the beam, which is 102. So 102, converting it to meter, it's going to be 0.10 pi. On both sides, it's going to be, the top angle is going to be on both sides, and it's going to be on 7 beams, because both the one with the A or B configuration in its arrangement are all going to have top angle. So that's why we just put 7 there. Yes, you multiply that. So for the bottom angle is similar. So for the bottom angle, this is uh values we were given. My drawing 76 by 152, 11 mm thick, 2 kg per meter. So taking the width of our beam is going to be 102. Okay, for the bottom angle plate, so is the values we're given 76 by 152, 11 mm thick. Really going to take the width of the column. So that will be all for the. So now we'll move to the built-up girders. And from our drawing, is from this point to this point is where we are going to be applying the built-up girders. From here to here, 6 meter. So in total is 12 meter. But to get the actual length from here to here, we still do what we've been doing before. So we're going to be deducting half of this, and this is 127, 127 mm. Add it together, 254 mm. Change it to meter, 0.254. So you subtract that from 12 meter for us to get the actual length of our built-up girder. So that will be 12 meter less half columns is 2 by 127, and 0.254. 11, that will be 11,746. Okay, so once we are done with that, move on to um, measuring for its various parts, such as the flanges, the angle cleats, sorry, the stiffness, the web. Those are the things we measure for. All right, so once we have our length, the next thing we do is just to get like a preamble. It's a preamble, so that we won't need to or describe for the web, flanges, and stiffness individually. So now for the first, from our drawing, for the flange. So the thickness is 15 mm, and its width is its length is 200 mm. Yes. So the entire length is 11.75. That's the length of beam. So that's what the flange is going to take. So it's going to be 11.75 by 200. So 200 is the width, 11.75 is the length. So book that. And by 2, of course, you have your flanges on both end, one here and here. So just multiply by 2. So then let's describe a bit. In addition, um, complete our booking. This will be 4.7. Okay, so once we are done with that, we'll move on to the next, which is for our web. So now for our web is also going to have the length of 11.75, which is from this point to about this point. Then its width is going to be from here to here, because this middle section that's in between the flanges, that's the web. That's this, like this letter I kind of shape. Okay, so from here to here is 700. It's having a thickness of 20 mm. So 700 mm, that's the width, whereas the length is 11.75. So we're going to book that now. The web is just one, so we have 8.23. It's 20 mm. All right, once we're done with that, we go to the stiffness. So our stiffness is at 1 meter center to center. So what that implies is that the placement from one stiffener to another is separated by a 1 meter distance. So what we do now to get the number of stiffeners we'll be needing, and knowing that is at 1 meter center to center, to find the number of stiffeners, so we take the length, which is 11.75, as the length of the flange or the beam. So we divide it by 1 meter here. So we're going to have 11.75. Of course, approximately is going to be 12. And you know, in measurements, anytime you divide, you add 1. So it becomes what? 13. 13. Okay, now for us to book, we've gotten the number of stiffeners we'll be needing. But however, we've not looked at its dimensions. So for the stiffeners, it's going to have a width of 75. Width is going to be 75, while its length is going to be 700 mm. It's having a thickness of 15 mm. So let's book, which is 0.70, which is, and its length that was 75, approximately is going to be 80. And how many stiffeners are we going to have? It's going to be 13. But it doesn't stop there. We're going to add by 2. Why? Because the stiffness is going to be on both sides, this side of the flange and the other side that we cannot see. So that's why in our drawing we use this dotted line to indicate that stiffness is going to be at the opposite side. Good. So doing the multiplication, we'll have 1.46 here. So then we'll go to allowance for fittings. Similar to what we've been doing. So for the top angle, now we have 76 by 76 by 11. So um 76 by 76 by 11 mm. In this case, what's going to be the width we'll be taking? So the width of the flange is 200 mm. So automatically our angle cleat is going to take this length. So this is 76 by 76, then this is 200 mm. So it's going to be by 2 on both sides at the top. Then go to bottom angle. Zero 0.20 by 2 is going to give us 0.40 as well. So 102 by 152 by 11. This is also 2 kilogram per meter. 2 kilogram per meter. All right, guys, we've come to the end of our video. Please do give us a like, share the videos too. Or maybe there's a particular topic you want us to treat, leave us a comment so that we can make a video concerning that.